Hello, everyone. This is Zeshun Shi from TU Delft. I'm very happy to introduce our component, which is called REWIRE blockchain infrastructure. So let's start. The motivation of our component. So currently, IoT devices often transmit sensitive data over networks, which can be easily tampered with. To handle this, we will use blockchain technologies. Basically, we will use distributed ledger technology to ensure data integrity through immutable records on the blockchain. Another challenge is data trustworthiness. So we need to ensure that the accuracy and reliability of the data collected from the IoT devices. So to handle that, we will implement a blockchain Oracle solution, basically to finish the data filtering and the data veracity check functionalities, and to confirm the trustworthiness of the data. And finally is privacy and security issue. So we will use both blockchain and SGX-based Oracle solutions to handle this problem. Our technical response may include, firstly, we use blockchain, especially the permission blockchain technology, to enhance the security and controlled governance. And we will use smart contract for automation and for compliance enforcement. And we will also use the off-chain storage, which is used to optimize the performance and scalability, because we cannot use blockchain to store all the data. And next one is SGX-based Oracle. So basically, we use this Oracle service for data processing and especially for application-related data. And we have another component, which is called FPC-based Oracle, Fabric Private Chain Code. So that part will be shown in another demo. In this demo, we will focus on the XGX-based secure Oracle components. And this is the roadmap of our work package 5. And this demo will cover those parts, like we will use secure Oracle to fetch data from the data source from some IoT devices. And then we will push those data to the Ledger Basu blockchain. And basically, we will store the data pointer on the blockchain, and we will store all raw data on the off-chain Elasticsearch storage component. And for our experimental setup, we use blockchain infrastructure. We choose to use Ledger Basu. It's a permissioned blockchain, and we deploy it on our cloud server with 4 nodes. And we use the POA, Proof of Authority Consensus Algorithm. And we deployed 2 front-end interfaces here. The first one is a blockchain explorer, and which is used for basic block and transaction information query. And we have another Grafana dashboard, which is used to monitor the underlying blockchain metrics and performance. We have 2 smart contracts deployed, application contract, which is used for user interaction, and the Oracle contract, which is a parent contract, and it can be used to manage the Oracle logic and interact with the relay and enclave components. For our secure Oracle setup, we run it on a local machine, basically a MacBook Pro. And basically, the secure Oracle components include 2 parts. The first part is a Python-based relay component, and the second part is SGX-based enclave component. For the off-chain storage, we use ELK stack, and we also build a Kibana dashboard for our Elasticsearch database. And for the data source of this demo, we use the external data source. Basically, we use the MemoPol API to query the current Bitcoin transaction fee. But this is only for the demonstration purpose. We plan to extend to real-world IoT application data from our use case partners in the next step. So the entire data flow of our demo will be a client user sends an application data request to the blockchain, and relay will detect the request and initiates data retrieval from the enclave. And the enclave will fetch the data, filters the data, and the data will be sent back to the blockchain. So basically, when the data is uploaded to blockchain, we have two approaches here. The first one is that we upload the raw data to the blockchain. This is the case when data size is manageable. But for larger data sets, we will first store the raw data on the off-chain storage, which is Elasticsearch, and we will only store the data pointer on the blockchain. For our plan, so for the next step, we plan to integrate advanced technologies, like we will integrate our components with the AI-based misbehavior detection component, also with the FPC part for secure attestation data processing. And we will extend the data source to the real-world IoT data source. And we will develop decentralized Oracle solutions in the next step. So that's our plan. So now let's look at the demo part. First, let's take a look at the front-end interface. So this interface is a blockchain explorer. Basically, we can view some basic block and transaction information here. We can also see the node information. Here we can see that we have deployed a 4-node Bosu blockchain. And also we can use this page to deploy smart contracts. Next page is a Grafana dashboard about the matrix and parameters of our blockchain. We can check parameters like block time, like blocks behind information, and also we can monitor CPU and memory information. And the next page is about the off-chain storage component. It's a Kibana interface in this page. So we can check the data stored in our Elasticsearch database. Okay, now let's go to the secure Oracle components. As you can see, there are 4 terminal windows here. The first tab is used to start our SGX enclave service, which is mainly used to fetch and filter the data in the enclave. The second window is our relay component, which is mainly responsible for listening to data requests, notifying the enclave, and transmitting the data fetched by the enclave back to the blockchain. The third window here is a client, which is used to send data requests to the underlying blockchain. And the fourth one is a monitor component, which is used to listen to the real-time data stored on the blockchain. Okay, now let's get started. We can start the enclave service at first. So we can see now here the enclave has been started. And the Oracle service is running. Next, we can start the relay service. Okay, it's running, and we can start a monitor here. Yes, and finally, let's start the client and send a data request transaction to the blockchain. Okay, we can see the transaction is successful, and from the enclave and the relay window, we can see that the transaction is processed. We got this response message. And in the monitor part, we can see a new data has been uploaded to blockchain. Here the fetched data is 13. So here we just try to query the data from a third-party API, where we try to query the fastest transaction fee of Bitcoin. So this is only for the demonstration purpose. Now we can also use curl command line to test the results. Okay, we can see here from the API, we will query the data about those fields. like a farthest fee, half-hour fee, and hour fee. But after the data filtering, we only store the farthest fee data on the blockchain. I will also show you how we can store the raw data on the off-chain storage, that is Elasticsearch, and store the data pointer on the blockchain. This is very useful when you want to use Oracle to fetch the large-scale data sets. We will start a new relay component and monitor group components. And we will send a new transaction request. So here we can see that the transaction is successful and the raw data is uploaded to Elasticsearch, and the data pointer is uploaded to blockchain. So if we click this link, we'll see the raw data. Also, the database interface is here. This is a Kibana interface for the data we stored in the Elasticsearch. Okay, that's all about this demo. Thank you very much. Thank you for your attention.